Hey guys, I'm Jake. Today is my LeetCode review vlog on 155th problem, min stack. We have to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. We have to implement the min stack class with several methods here. And we have to implement a solution with big O of 1 time complexity for each function. Let's see example 1 here to understand the problem easily. We got some operations and numbers as input here. First, we'll create a min stack instance. Then, we'll push -2, 0, -3 into the min stack. Then, we want to get the minimum value so far, and which is obviously -3. Then, we'll pop the -3 value. And then we want to pick the top element, which is 0. And for the last state, we want to get the minimum value so far, and which is -2. Then let's get started with our intuition to solve the problem. First, as far as we know, the primary difficulty is to maintain the minimum element accessible at big O of 1 time complexity. And we also have to ensure that the basic stack operations like push, pop, pick also run in big O of 1 time complexity. So if we want to achieve this, we can consider the approach is called single stack with tuple data. Single stack with tuple data. We can make each stack element to hold both the current value and the minimum value so far. Then, let's get started with a code to solve the problem. Oops, I typed some wrong word here. First, we have to create a private member variable. Let's call it stack. And the code is private stack. And the type of the element is an integer array. And the name of the member variable, let's call it stack. And each element in this stack is an integer array. And the first element is the value itself. And the second element is the minimum value so far. Then, inside the constructor method, we have to initialize the stack variable to a new empty stack instance. Then, we have to implement the push method. So inside the push method, we have to push an array with the value itself and the current minimum value so far. And the current minimum value is from the smaller value of the current value itself and the last minimum value from the last array. And there are two cases. The first case is if the stack is empty. In this situation, we just push a new integer array. And the value and the minimum value are both the value itself. Stack, push, a new int array. The value is value itself, and the minimum value so far is value itself too. And on the other hand, if the stack is now empty, first we want to get the current minimum value from the last array, and we can pick it, which is int current minimum value so far equals stack dot pick. And we want to get the second element. Oops, it should be 1. Then we have to push stack, push a new integer array, new int array. And the value is still value itself, but the minimum value so far we have to compare them with the math.minimum method, and the two comparator is, and the two value to compare is the value itself and the current minimum value from the last array. And that's all of the code for the push method. Next, we have to implement the pop method, and which is very easy. We just use stack.pop. And next, we have to implement the top method, which is equivalent to the pick method from the stack, which is return stack.pick. But we want to get the current value so far, so it's the first element of the array. And for the last method to be implemented is the get minimum value. We just return stack.pick. Then we want to get the second element, which is the minimum value so far. And this is all of the code. Then let's check the correctness and analyze the time and space complexity. So the time complexity, it is big O of 1 for all of the operations and methods. And the space complexity, it is big O of n. This is because each element in the stack could hold an additional integer, but the space used still scales linearly with the number of elements in the stack. And in the worst case, our stack could hold all the elements. And yes, our code got accepted. And this is the end of my LeetCode review vlog on the mixed stack problem. And I highly recommend you guys to visit my online GitHub page here. You can see all the notes for the top 150 LeetCode problems. And for the mixed stack problem here, you can see the problem description, intuition, different solutions with Java code and annotations, and the final time and space complexity analysis. And you can also visit my GitHub repository here with the codes and notes to build the online GitHub page. And I'll put those two links on my YouTube description below. And thank you guys for watching. I'll see you next time. Bye bye.